Welcome to Human Tech, a podcast about the intersection between humans and technology. My name is Guthrie. I'm here with Susan. Hi, Susan.
Hello, Guthrie.
And we also have Mr. Dean Barker here again. Hello, Dean.
Hello, Guthrie. Hello, Susan.
So this is going to be the next part of our. It's a part of a series, and so we have we're gonna do a whole bunch of topics that Dean and Susan wanted to delve deeper into. Last time we talked about objects and views, which is very important and sort of nuanced. And so we didn't get through everything, and that's fine. So we're going to kind of pick up where we left off. If someone could very briefly just do a little 1-minute summary of what objects and views are, just so that if anyone didn't listen to the previous episode, they have at least some understanding of where we're at. Is that possible?
He didn't ask us to do this before we went on the air. Did you notice that?
No, there was no.
Yeah, we had a whole conversation about what we were going to do, and there was no mention of start with a 1-minute summary on objects and views. Okay, Dean, you or me?
Or I can do it.
Go for it.
Oh, we want to hear that, Guthrie.
It's going to be wrong.
Let's hear your summary.
There's a way to break down interfaces and the way people sort of interact with them. And it's very theoretical and abstract. And it's a concept called objects and views, because there are objects and there are views. These are two different things. If I recall, you guys decided that objects were nouns.
Mm-hmm.
And how would you describe views? I don't know if I can do views correctly.
Grammatically, what's a view? So an example that we gave is, if you're using an app to schedule your appointments in a day or a week or whatever, the object might be the calendar, and then the view might be, it's the monthly view, it's the daily view, it's the weekly view. So from a grammatical point of view, we do not have any English teachers on the call today. But Dean, what would you say if objects are nouns, then views are?
No, they don't. I don't think they correspond to grammatical whatevers.
No, views are still going to be represented.
They're still going to be a noun.
Yeah, they're still going to be a noun. But the
if
important
objects are nouns, views are also nouns.
Yes, but the juxtaposition is really objects and actions, right? So
that's the objects are nouns and actions are verbs. However, within the object, you may have one object with multiple ways of looking at it.
So if anyone didn't listen to the previous episode, it's not intuitive and it's not super simple, but it is very powerful. And
you might want to go and listen to the previous episode.
Yeah, because you guys are here today to talk on at a high level, because you have supreme understanding of UX between the two of you.
We are supreme beings, like in a sci-fi movie.
Not quite. Yeah, supreme UX beings.
It's all a simulation anyway. So.
Okay, so with that, just so if someone wanders in, they're like, "What is?"
They're
going
like,
on?
"What?" Yeah, that's good. All right.
So, Dean, I'm assuming that you had a place that you wanted to pick back up then in our objects and views discussion.
Yeah, I wanted to pick up where we left off and kind of dovetail. So the main thing I'd like to talk about today is, to quote David Byrne, "How did we get here?" Right. So I want to kind of go through a timeline of technology and how we ended up in this place where we're even talking about object orientation. But there was some interesting conversation. Guthrie, I think near the end of the last podcast, you were teasing Susan and I about being old and throwing paper airplanes or some such thing, and that led us into a conversation about iconography, right? So this gets to icons and metaphors, and that's all related to the whole notion of objects in a user interface. Which, by the way, when you said earlier, we decided that these things are nouns, or we didn't decide anything. We're drawing really from a rich body of knowledge, and I think that's kind of the point of this. Not just this discussion on objects, but other things Susan and I have been talking about lately, is that I suppose one of the benefits of being old is that you're familiar with all these bodies of knowledge and all the literature that's come before, and we're trying to share some of that, and indeed even refresh it and modernize some of it. But
Yeah, and I think one of the problems with getting there are many problems with getting old, but one of the problems with getting old in this field is that I think is that you'll run into situations where people will go, "Oh, well, there's this new thing called X," and it's like, "Okay, that's not new." So I agree with you, Dean, and I do not want to imply that at all that I invented this whole thing with objects and views because I did not invent it, and it actually I'm not that old. It actually predates me, luckily. So yeah,
well,
that's a good thing to comment on.
I'm gonna do a little foreshadowing because
Yeah,
I'm gonna take our origin story here in a few minutes back to 1791. So
that definitely predates me. There's no doubt about that. That's good. I'm not even pretending.
But before we get there, to pick up on the paper airplane story, I just a minute on an idea and kind of a field within a field that I think is useful for folks in our industry to think about. So when we were talking about the conversation that Guthrie kind of initiated, I think the last time, and the whole idea of paper airplanes for the send icon, and we were talking about other icons.
Sending a message in
Yeah.
a lot of apps is a folded paper airplane for
Yes.
obscure reasons.
Well, yeah, not so obscure. I think we figured it out, but I think that whole thing about iconography and images and pictograms is there's this notion of redundant coding, meaning that if you have a button and you have a word on it as a label, obviously that's explicit, but then the icon itself, which can be used with or without a label, has its own semantics. These are visual semantics, right? And so that the study of that from an academic perspective, which is very useful, is something that I picked up from studying years ago with Aaron Marcus. Susan, somebody definitely that you're familiar with. Our listeners be familiar with him. He's got an interesting body of work, and he's a longtime HCI UX expert, and has a very interesting academic as well as professional background. But I took some summer workshops with him, and he introduced to me the field of semiotics. And semiotics is the study of signs and information. And we won't turn this into an exercise or a lecture on semiotics, but just I wanted to pick up on that thread and say, hey, this is a thing that exists, and something that people in our field should be aware of. And the fundamental breakdown of semiotics is that it's a lens through which you can view the communication of information, and the paradigms are not dissimilar from linguistics. You have semantics, meaning. You have syntax, meaning structure or organization. And then you have pragmatics, which means in use. So it's not unlike in usability how we talk about the context of use and the actual usage case as being independent from observing or measuring usability without usage, which you can do. So in the ISO world, for example, you've got a definition for usability, which you can assess with or without actual users, but then you have this construct of quality in use, which takes actual users. So the pragmatics of semiotics is really interesting because that gets into what we do from an interaction design standpoint and whatnot. Anyway, maybe we at some point could do a whole thing on that, but it's a really interesting area and something I would encourage people to check out.
Yeah, that's good.
That was it.
Okay. All right. So we closed up that conversation from last time. So where do you want to pick up from here, Dean?
Well, I wanted to talk about how we got here and sort of the evolution of technology. And what got me thinking about this was some reading that I had been doing. I brought some books.
Oh, so what a shock.
I know. One of them, this is a really good book. It's called Dealers of Lightning. It's the Xerox PARC story, and it's an interesting thing, I think, in our field. So, and maybe this gets to the whole generational thing as well. But everybody thinks about the kind of the creation myth of Xerox PARC, right? Like there was this big bang, and everything in our world of GUIs and objects sprang forth from this monumental event at Xerox PARC. And uh, not to diminish the role that institution and some of the things that happened there played in where we are today, but I guess my fundamental thesis is that where we are in computing today has been such an incremental evolution of technologies and a convergence of technologies that this kind of mythology around Xerox PARC is an important.
Wait. Okay, but I have a question, Guthrie. Being of a different generation,
Yeah.
what is, if just if you hadn't been talking to Dean, what would you, where and when and who would you say was the origin of graphical user
No, this is
interfaces?
not fair. I know about all this. I've heard you talk about this like 1,000 times.
Oh, well, but what? So, do you have a sense? If you hadn't heard me talk about it, what do people out there generally think? You don't know,
People on the street, no,
because
no
I
one
think
knows about
people
Xerox PARC.
think. I
Xerox
think,
is dead. No one knows
yeah,
about them anymore. So
maybe
that
Apple.
Right.
I would say that there are probably no. I don't even think people know about that. If you're
Yeah,
if you are a UXer and you're interested in design and you're
yeah,
interested in UI
yeah,
UX,
yeah. That's what I mean.
you're probably like an Appleophile, and you probably know about Steve Jobs and the early, computers and maybe some feuds with Microsoft, and you may know some of the history, and there's
Yes,
been a couple movies about it. So I would imagine that you probably just assume it's early PC stuff or
yeah,
IBM. I don't know, they were
yeah,
doing stuff,
yeah.
sort of like
IBM or Microsoft or
it
Apple.
wasn't
I
it's
don't
a
even think they know about that many people know about Xerox PARC.
but part of the strange uh, disconnect is I think the tech industry is so huge now. I don't think maybe people my age or younger would have a grasp that a place would be influential. Like it was it was so much smaller then that you
Mhm.
could have like a guy who invented a thing, right? And like because like Google is like the sprawling, everything's done on the scale of like a team of 8,000, and there's like this sprawling, nothing is done. Yeah, like
A
I don't think.
guy.
Yeah, there's not just like a guy who's like invents a new way to do the internet or
Right,
something. It's
right,
just
right.
so the idea that there would be this building that invented all this stuff, it
Or a team that
it wouldn't occur because
worked on
like,
all
well,
this.
why would that's like way too small.
Yeah, interesting.
So
Okay.
I think in my guess is that it sort of amalgamates to they were big companies back then, like IBM or like Xerox or some other, or Apple or whatever, and they were working on stuff and they did a bunch of stuff back in the day. But it's not. So it's not. It's more just sort of like a ancient computer history,
Generalized thing. Yeah.
generalized. That's my
Okay.
guess.
Thank you. I appreciate that. All right, Dean, pick back up. You're saying, okay, even if you know about Xerox PARC, that's not the
I
true
haven't
origin
read the
story
book
either.
about it that you literally have in your hand.
Highly recommended. But then again, I've got about 6,000 books that are highly recommended. So I'm not
He's
sure
not exaggerating either.
This is
That's like
this
an
is the
actual
old
number.
NBA paradox in which people who talk about the NBA, whenever they talk about anyone who's good,
That's
they say,
true.
"Oh, I mean, he's a top 10, he's a top 25 player in the NBA." But they say that about like 100 people. So it's like it can't actually be true. So it's sort of like you with books. Like this is like I have to read book, but like they're all have to read books. So right. So then
Yeah, what I had a conversation just this morning with my 12-year-old about Allen Iverson, right? Trying to school him up a little bit because it's exactly what you say, right? Like everybody's perspective, like all my kids all think that LeBron is the GOAT, right? So anyway, we won't get into that. That could be its own entire podcast episode. Okay, so 1791, Washington, D.C. was created, and the steamboat was invented. So that's a little historical context for where we begin our story. I would contend that in 1791, the invention of the visual telegraph is the beginning of our story. So that was a telegraph system that was the first visual display. It had I don't even know how to describe it. It was a structure, kind of an H-shaped structure, I think, that had shutters. And you could use electronics basically to create different configurations of these shutters. And back to the whole idea of semiotics, you know, there's meaning to how that
There would not have been a display using lights because light bulbs had not been invented.
So there you go. We could tie the invention of the light bulb into our story. This is the fun thing, by the way, about.
So when you say display, I'm just to the people out there. You need to don't think about like
no, it'd be
lights
like
on a grid.
A mechanical board,
right.
Yeah.
So
that's something would move.
Exactly, and that's
not that I was around.
Thank you for clarifying that. Yeah, so I would contend that because what we're talking about with objects relies in large part, we'll get to special cases like speech interfaces and whatnot at some point in our conversation, I'm sure. But basically, we're talking about visual interfaces, right? Like the very notion of the GUI, the graphical user interface, is itself inherently visual. So what I was thinking about is that really it's about, we use this phrase screen time, right? So the story really is largely a story about screens and what's on screens, right? And so that's why I trace it back to that event. And then if you fast forward a little bit to 1897, computer display enabling technology was created. That was the beginning of CRTs. So it was a German physicist, Ferdinand Braun, 1897, and invented this tube that then enabled the CRT displays that became the military displays and the televisions that we knew growing up before 4K or 700.
Cathode ray tube.
That's right, cathode ray tubes. And so you have to think about computing in terms of inputs and outputs, right? And so what we're talking about with these displays are the primary outputs. Yes, you can output to a printer and whatnot, but when we're talking about display technology, there's an actual history there. On the input side, in the 1930s, I think the first GUI input technology was created, and it was something called the light gun. And the light gun operated on a cathode ray tube display. And
cathode ray tubes are very cool, underratedly cool.
I'm glad you have an appreciation for it.
I don't think people understand actually how they work.
Do you know that? Okay, shoot. Now I'm not going to know. The guy who really got, I know there was the guy who invented the cathode ray, what you were talking about, Dean. But then there was a different guy that really was the one to get it going in modern, the idea in modern use for television. And he, oh shoot, now
it's
I'm going
the Potato Man.
Yes, the Potato Man. What's his name?
Who is the Potato Man?
What's his name?
I just remember the potatoes. I don't
so he got the idea for the. All right, so
okay, hold on. I'll have to back up. A cathode ray tube is very cool. It is essentially an electron gun that shoots particles, photons, light out of a gun. There's a generator and an accelerator, and it shoots it out. And the way they were originally invented, like a gun, you point it and you shoot it, and it shoots in a straight line because it's shooting out. So they realized that if you put coils and magnets and stuff along the barrel of the gun, you can bend it because it's, you know, so you can sort of place where the bullet goes. And so if you fire a lot of bullets, you can create a picture by firing, you know, bullets really, really fast. But what pattern do you use to sort of fire them? And how can you transmit that data in a way where you could, okay, fire a black pixel here, a white pixel here, a black pixel here, once they had color, you know, that. How do you display a picture at a time if you can only fire one bullet, one pixel at a time? And so there was allegedly this guy who was a potato farmer, and his whole life, all he did was go up and down rows of potatoes, just rows and rows and rows of potatoes. All he had was a potatoes rows and the potato thing, and he'd go one plant to the next plant, and then we get to the end of the row, go back the other way. And so he was like, wait a second, what if we fire in lines that go down like a row of potatoes? And so that's how the cathode ray tubes work, is that 60 times a second it fires the entire line one at a time. And
supposedly got that
and the
from
way that the
looking at
data
the
is
potato field.
transmitted over the air, when they had television that would display that, is you would display the pixel that would need to be fired from the
Right.
top over, and so you could send one pixel at a time
over the air,
and then it'd be displayed into that's the frames.
So the potato farmer had a neighbor who was a corn farmer who was very upset.
This part is not true.
He was very upset because he thought, I should have thought of that.
All right.
But
this could be apocryphal.
But that's on the that is on the display side, right? So these images that the listeners are getting of, hey, shooting rays out into the pixels is kind of from behind the glass toward the glass. On the other side of that, the next milestone is this invention of the light gun in the 1930s. That's really the first gooey input. And the light gun looked like a glue gun, right? Like you would expect a gun to work. And that evolved into the light pen. But now you have this CRT display and you have an early input, right? This is way before the mouse, even before keyboards. So now you've got the key output and the key input. And then in 1932, the oscilloscope was invented. That was made by Raytheon, and so you can think of that shows electricity. It's an electronic display that shows voltage, right? Like an EKG is an example of an oscilloscope. And so that's part of the evolution of this series of technologies, and even the enabling technologies that play into the story of how we got to this notion of screen times and nouns on screens, right? And so the light gun evolved in 1936. There was a thing called I need to look at my notes, the Seeburg Rayolite. The Seeburg Rayolite was an arcade game. It was a duck shooting game. So it was like a standalone, like the Pac-Man machines that I grew up with or whatever. But you went and you used the light gun to shoot mechanical ducks that were going across the display. And so that whole notion of displays is really important because that converges with computers. So in 1945, the first programmable electronic sort of general purpose digital computer was created. It's a story that a lot of people know. It's called the ENIAC. It was created at the University of Pennsylvania. And the output was a transmitter panel, I guess. It's a series of panels. So you look at it and you see these switches and these dots and these dials. You don't have yet a video screen, right? Like we think of computing now. And the input was a card reader. So you don't even have a typewriter at that point in 1945. So the place where this all came together, and I know you're going to be surprised, I actually have a couple of books on this. Let's see if I can find them here. There is a great story here. There's one about sort of the general. We should get affiliate links. Can we get affiliate links built into this somehow? We should monetize this whole thing. There's a whole. There was a program, many programs of government support for computing research. There's a book that documents that called "Funding a Revolution." But the one that was particularly interesting was about this event in 1951, Project Whirlwind. There's a book on that. The History of a Pioneer Computer is the subtitle. Whirlwind was the first computer with a light gun and a direct keyboard input and a CRT screen, right? So that's the first time where you have a computer with a keyboard for typing and a mouse-like input. It wasn't a mouse yet, but that's the first one to bring it all together. It was developed at MIT for avionics. It was basically a radar air traffic control simulation, and I would contend that that was the first instance of digital objects on screens. So you had, the context of a radar-like display, and you had little icons, stick figure airplanes, right? And so now we're at a point in 1951 where arguably these technologies have converged to give us things that would be familiar in a modern computing context, right? They would seem archaic as much as anything else, but they would at least be familiar. Then that same year, there was a business computer that was created. So keep in mind things like the Whirlwind and the ENIAC. Uh, Susan, you can describe this. Your experience even early in college and whatnot with computers. But I'm sitting here on my little 13-inch MacBook that I tote around everywhere with my iPad for my notes. These are very power computers. What was a computer like physically back in the day? Describe that for the audience at home.
Well, I only know about this from what I've seen in old movies and read in books. It's not as though I would have experienced this personally because I'm not that old. Okay. The truth is, I am that old. So, well, and I was thinking as you were talking about there's just all these interesting evolutions. Computers, not really that long ago, were gigantic machines, actually multi machines,
Right.
because there was the disk storage, which was one thing, and then there was the actual computer doing the computations, which was another thing, and these were, I mean, you had entire buildings that how you needed a big building to house the computers and all this peripheral equipment that had less capability than you have in your iPad. Less capability probably than in my Android phone. I mean, these were big buildings full of machinery, the capability of which, was thought to be very powerful, but by today's standards was not.
Yeah, my iPhone has more computing power than the computer that put the Apollo on the moon. Right?
Yeah.
I mean, that's crazy to
Yeah.
think of.
And so it was really big. I mean, these things were really huge.
Yeah. So when we're talking about a computer, right, like the Whirlwind or the ENIAC, that's what we're talking about, right? And these things were, millions and millions of dollars. It was not something that you just had in your home. And so
Right.
as the story progresses, then in 1960 is the invention of the term hypertext and hypermedia. A fellow named Ted Nelson created that for another kind of research project called Project Xanadu that you can look up. It never quite worked. They couldn't quite get it to work the way that they aspired to, but the idea was there, and the term came out of Project Xanadu. Xanadu. in 1963, going a little bit forward, there was a thing called Sketchpad that then leveraged the whole idea of the light pen and using that with a CRT. And that was an application for, it was at MIT, and it was for CAD CAM, computer aided design work. And then in 1964, I think we finally get to a mainframe that is something, again, that would feel more modern, still big, ginormous. The IBM 2250, it was in 1964, still a giant machine, something that'd be like $2 million today in terms of machinery. But it had all the things that Whirlwind had, the light pen, the keyboard, but it also had software that would be familiar. And it had CAD software, hypertext, other things that would be familiar. I think it had the light pen, which eventually led to the joystick and the trackball and the mouse, right? So all of these technologies sort of evolved independently and converged, and our history has really been one of sort of weaving in and out of all of these things. As it pertains to what we're interested in from an object-oriented perspective and in user interface, user experience design, in 1964, Louis Pouzin introduced the concept of the menu. And that is something, I think this is it was between MIT and DARPA. But I would say that menu is sort of the origin of the first modern GUI paradigm, right? That idea of an actual menuing system. And a lot of these things come together. Oh, by the way, menus, a point I wanted to make about menus, because we were talking about paper airplanes and icons and metaphors and everything. It shouldn't be lost on people that the very idea of a menu, the term, right, like, comes from, where would you suspect it comes from? Guthrie, where would you say the metaphor of a menu in computing comes from?
Lots of people getting lunch together.
Right.
Actually, yeah.
From an actual restaurant menu, right?
Yeah.
Which had to be invented. The menu, as we know it in restaurants, was invented in the 1700s in France. So you can even tie that into the story, which I probably just did poorly. But all this stuff converged in 1968 as something that is referred to in computing history as the mother of all demos. And this is really an interesting major milestone on our journey here. A computer pioneer named Douglas Engelbart, who's really known as the father of human-computer interaction. He envisioned a computer system that used an operating system with a Windows-based operating system, video conferencing, hypertext, sort of the pre-GUI GUI. He had envisioned all of these things and did some prototyping work at the Stanford Research Institute, and he created a GUI prototype. It never got any sort of commercial traction, rather. Didn't go very far. I believe he also invented the mouse. He was the inventor of the computer mouse. And this demo, which I should have looked at it recently, but it's been a while since I've seen it. I think there's a video of the demo on YouTube that you can go and look at. That is all the stuff, and again, this was at Stanford, that led to Xerox PARC, right? A lot of the people from that SRI Institute at Stanford ultimately went to work at Xerox PARC in the early 1970s. And so all of these technologies came together and converged to PARC, which is, I think, sort of the history that people who are curious and think about and know understand to be kind of the big bang of all this GUI technology that we think of. But it really happened before that. So I'll pause there, and then I want to go through the golden era of GUI evolution, which is from PARC to where we are today. And Guthrie, as you said, you hit it on the head. There's this mythology and this culture around Apple and Microsoft and movies like the Pirates of Silicon Valley and things like that. And all of that stuff is sort of the 70s to 90s, but there's all this prehistory that I think that's really fascinating that allowed us to get here. So,
all right, I got things I want to say. No, but because as you're talking, I'm thinking, and I'm going to be honest. Some of what I'm going to talk about now is a lived experience. Um, it is fairly recent that non-computer scientists interact with computers. So, you know, it, originally, if anybody who interacted with a computer, and that means writing the program or getting the data out of a program, those were specialized computer scientists. A regular human, no matter what your job is, would not ever interact with a computer. Now you may have received, and I'm talking about going back in, as far back as the mid 70s and before, you may receive a printout of data or information from the computer that somebody hands you, but you would never have done anything. You would not have been the one to communicate with the computer at all. That would have just been a computer programmer or something called a computer operator. And so you had specialists doing this. So this work that you're describing, Dean, about, okay, the origins of the mouse and the origins of this, that was all that. So that's one point. The second point is that a lot of the things you're describing was research and innovative ideas, but it took an enormous amount of work to actually like create and manufacture computers. And so if you were a business and you had enough money to buy one of these gigantic things, the things you were buying were not the innovative things. You didn't have screens. In your computing building, if you were a business and you were wealthy enough and high tech enough to have a computer, you had in your building a teletype type of machine.
Right.
You did have a keyboard to
Right.
talk to the computer and program the computer, but there was no screen. It was like paper going through, and you would type on the keyboard and the computer would type back to you. And that would appear as a typewriter. So there were no screens and there were no mice. So even though that was being worked on and invented, that was not being manufactured for quite a long time. That took a long time to come into regular use. And when it did, it was still the computer scientists. And I was around and active in the field when that switch happened to where regular people, not computer scientists, started interacting with computers. And that was a really strange switch. And that was, and I think that's when that really pushed, and I agree with you, HCI, human computer interaction, man machine interaction, which is what things were called a long time ago. That was all happening before this. But when that switch happened and all of a sudden regular people were actually now interacting with the computers, that's when the whole, usability and human computer interaction really exploded, because you couldn't, if you had a really difficult interface, which everything was, it wasn't designed for regular people. It was designed, all the interfaces, all the interactions were designed for specialists. That just wasn't going to fly anymore. So you went from having this tiny group of specialized people interacting with machines to, millions of people interacting with these machines and the software. But so that's just remember that even though some of this stuff was being invented, it doesn't mean it was in use for. It took quite a long time.
Yeah.
To get the manufacturing going, right?
Do you remember the show The X-Files?
I know of the show The X-Files, but I'll be honest, I've never seen the X-Files.
So it was I guess, sci-fi-ish kind of show.
Yeah.
I used to very, very much enjoy it, but it was the tale of these two FBI agents who followed all of these interesting cases where, there was suspicion that there might have been aliens involved or some other paranormal sorts of things. Anyway, I remember an interview with an FBI agent, and they had interviewed this FBI agent about, well, how realistic was the depiction of the life, the paranormal stuff aside, the life of these FBI agents. And he said there was not enough paperwork shown in the show. That was the thing. And so I think people fail to understand that the way that business got done, the way that work got done, whether it was businesses or universities or whatnot, was just pushing a lot of paper, right? Like there was paper everywhere. And that actually kind of plays into the story. And I know Guthrie has done substantial research on the history of paper, but where would we pull paper into the origin story here for GUIs? Because I want to tie that to Xerox PARC.
Paper is an ancient thing. There's really no clear way of what paper is. Paper is simply plant fibers that have been ground up and then dried, and they sort of the fibers. They're bulky and they kind of friction against each other, and when they're dry, they form a surface that's uneven that you can scrawl things on. So there's papyrus, there's blah blah blah. But if we're talking about modern paper, allegedly the oldest immediate precursor to modern paper, which would be like a wood pulp, is going to be the 2nd century BCE in China, allegedly. But at about 751, that's when 2 Chinese paper makers were captured as prisoners in an Islamic world battle, and then they started making paper, and then eventually made it to medieval Europe in about the 13th century, where you had water-powered paper mills.
All right, so our story goes back even further. So I love that. So we'll have to pull that in. So how does that relate to all the stuff we're talking about? Xerox PARC. We're now late 60s, early 70s, the foundation of Xerox PARC and sort of the mythology around the creation of GUIs and object orientation that we think of. And I want to go into the details about that. But the PARC story is somewhat interesting because of the fact that it was Xerox. Xerox had created the copy machine, right? The whole world ran on paper. Xerox literally had a monopoly on the copy machine. And so they were worried, and rightly so, because it ended up happening, that they were going to get antitrust suits. They were going to get in trouble with government regulations. They were making all of this money, big blue chip company, and they had to diversify. And so the Palo Alto Research Center, PARC, was created because Xerox needed to find new technologies and new markets. It wasn't exactly altruistic. It was created to be an innovation center. And the irony is that Xerox could have been Microsoft, could have been Apple, could have been IBM. So much stuff came through that laboratory and that incubation where they could have, where they either invented it or took it and took certain technologies and ideas to the next level, but they didn't really capitalize on monetizing it. But it's all because they had to get out of the paper industry, in a way, out of the whole idea of being a company that was nothing but copy machines. So,
all right, I have to throw in one more historical origin of technology. So you mentioned, Dean, at one point about cards punch cards, I think.
Yes.
Because, before the keyboard, that's how you talked to the computer. You would have a stack of these cards, and you would have used a special machine, and it would punch holes in the cards.
Right.
And those holes had to do with, 0 and 1 and on and off. And that was how you turned your lines of programming code because you couldn't type them in. So how are you going to get your programming code into the computer? You would it's so weird. You type them on a machine, but that wouldn't go into the computer. That would just punch the holes in the cards. Then you would take the stack of cards with holes in them, and you would put them in a special machine. Well, you wouldn't. The guy behind the counter would put them in a special machine called the card reader. And that would then be how the code went into the computer to run the program. And, if you ever dropped your stack of cards, man, you were not happy because you had to put them all back in order. However, that technology, the punch card, was developed in the very early 1800s, I think 1801, as a textile loom technology. So I had so much fun going to Lille, France, Lille, and it actually wasn't Lille. It was the town next to Lille, whose name I can't remember. There is a textile museum that is the most wonderful place.
Wow.
I loved it. And they gave this great tour. They have looms there that go back to the 1700s and then up to modern day. And in this museum, as we're going from loom to loom and doing the historical timeline, I'm looking up and there's these gigantic punch cards doing, and they still operated. They could still press the button and get the thing to operate. And I'm like, wait a minute, that's a friggin' punch card. And then I looked up and it was like, yeah, that's how the punch card technology got developed. It was in the early 1800s in France to program these looms so they could create these jacquard fancy textile patterns faster.
That is fantastic. So, see, this is the power of collaboration. We've taken technology timeline, and now we've brought paper
Yeah.
and looms.
Paper and looms and all of it together. Okay. So now where do we go, Dean?
Well, so now we begin at Xerox PARC and sort of the conventional history that people know. But I do want to go kind of through that incremental timeline because I think there's some number of people who do believe that Steve Jobs invented the computer, right? And it didn't really work that way. So the context of the technology that we're talking about with GUI. So GUI is graphical user interface. That's the visual interface. And as Susan, you were saying before that, prior to that, the way that computers operated is that you had punch cards, and you also had, while you had the evolution of CRTs, you still had computers even into the 1970s that were buttons and dials and red blinky lights, right? Like we didn't have the same kind of inputs and outputs that we're familiar with today. So related to the GUI technology is a very specific idea that you'll see in some of the UI design literature around what are referred to as WIMPs, right? Windows, icon, mouse, pointer. And those are some of the key ideas within the GUI. And so this really relates to objects, and there are some other enabling technologies, but let's go back to that 1968 mother of all demos. That was at SRI in Stanford. A lot of those folks ended up working at Xerox PARC. And there's some other enabling technologies. The first commercially available RAM chip, the Intel 1103, was released in 1970. That's when Xerox PARC was created. So now you've got the convergence of some processing power. That's also the year that Engelbart patented the mouse. Didn't invent it, but he patented it. And that was the year that IBM created relational databases as we know them today with table structures and whatnot. So then Intel introduced the microprocessor and CPU, which is the miniature brain of a computer, in 1971. And by 1972, you were starting to see some home game consoles. And we could take a whole tangent down the whole history of gaming and how that plays, but it's not a trivial thing. So Magnavox created the Odyssey in 1972. The Pong arcade game that was the first one that I remember having as a kid was created in 72 as well. They were sued by Magnavox, but the part that's interesting about that I want to bring into the story is the idea of color. Because previously, all the displays, whether you had a command line interface and you had a CRT, you had some of these visual things like the video games, all of this stuff was either green screen for character based or black and white displays. So keep
or
that
orange.
Or orange. There were orange screens as well, right?
That
But
was
there,
very cool if you had an orange one. That was special. That came from Europe.
oh, well, there you go. See,
That was very cool to have an orange. Orange was like, whew, you spent the extra money.
that was I came in the middle of the movie, so I didn't quite catch that from direct experience, um, but the display technology was not in color yet in the
Right.
1970s, and
It
so in
was not.
1973 there was the first personal computer using a microprocessor called the Micral. It was designed in France, probably had an orange screen.
Probably.
And then shortly after that was the precursor to DOS. So the digital operating system, which is how Bill Gates really got his start making his money. Microsoft kind of pilfered from this history of different evolutions of digital operating systems, but there was a thing called the Control Program Monitor OS, CP/M, which is one where you had a commingling of menus with a command line interface, but it also had charts and graphs, right? So we're getting to objects in more interesting displays. And then the big thing was the Altair 8800 in 1975. This was really instrumental in this story of Bill Gates and Steve Jobs and Microsoft and Apple. That was a computer kit that was created for hobbyists, still didn't have a visual display. It was all blinky lights and switches, but it was a build it yourself at home computer kit. Going back to Susan, what you were talking about, how people, didn't have computers themselves. They were these big things in rooms that were millions of dollars and whatnot that institutions like governments and universities had, and military organizations as well. But this Altair 8800, the electronic guts of it were really key. It was like a mini ENIAC. There was no keyboard or monitor, but it's what got Steve Wozniak, Steve Jobs' partner and co-founder, into building computers because he was an engineer and an enthusiast, and it's what got it's what got Paul Allen talking to Bill Gates about starting a software company that became Microsoft because the Altair needed software. It didn't have software, third-party software that was created for it. So that was really a major milestone in the evolution of Apple and Microsoft. Well, by 1976, then you had the Apple I, which wasn't sold with a monitor. It was a command line interface computer. The first prototype demo didn't even have a mouse, and that was what Steve Wozniak created, coming out of his experience in assembling these kits. And then in 1977, the Apple II really became the first consumer grade computer on the market, but it wasn't until 1979 in VisiCalc, which was considered the first killer app, that it really was a spreadsheet, sort of pre-Excel spreadsheet, that things really started to explode. So all the way through the 1970s, where you're getting is still green screens, command line interfaces from a consumer standpoint, and the most interesting thing that you have to work with is a spreadsheet, right? So that covers the 1970s. Then you go into the 1980s and things just explode. In 1981, Microsoft created MS-DOS, their operating system. It was a command line operating system. Again, there were several other DOSes that informed that, but they popularized it. And then in 1983, the Apple Lisa was the first GUI commercially available. It combined a keyboard and a mouse, and it was a black and white computer. It was not commercially successful. It was outrageously expensive. It was very clunky and kludgy, but it had all the elements that we would think of as a normal computer these days, right? In 1984, the Apple Mac came out, and it had some interesting applications, some interesting software on it, Mac Paint and Mac Write, but it was still black and white. So here we are in 1984. Computers are still black and white. TV had been in color since the 1950s, right? And then in 1985, Windows came out with a color GUI on IBM PCs. But this construct of windowing that we think of as a major construct, again, the WIMP idea, right? Major construct in object-based UI design. The windows in that initial version of Windows were tiled. There was no three-dimensional, no overlapping in that, right? It wasn't until 1986 that the Apple IIgs came out, which was the pre-Mac Mac. It was built on the Apple II foundation, and it was the first Apple computer with a true color GUI and windowing. I think this is really the big milestone. People sleep on, they forget about the 2GS, but that was really the computer that you would recognize today as the kind of computer that we use. They followed it with the Apple Mac 2 in 1987, a year later, with a color GUI. And then that same year, Windows 2 came out, which added true windowing, so you didn't just have tiling. And then in 1988, IBM came out with OS 2, which there was in the history of object-oriented user interface design. IBM's OS 2 plays a major role. We think about it these days really as Apple and Microsoft, but IBM had a huge role in that. They had partnerships with all these other companies, and they had their OS 2 operating system, and a lot of the object-oriented work that we think of today in terms of GUI design came out of the OS 2 operating system, not just
Yeah, yeah, and I agree with you, and as you were talking, again, I'm going back to my lived experience, 'cause I go back as far as a lot of these things that you're talking about. And from if you think about the software that was being developed and the HCI and usability work that was being done, that I was doing way back when, most of that was not anything to do with Microsoft or Apple, because most of it was going on in businesses. And they were using the IBM OS 2. They were using Digital Equipment Corporation and, PDP. And so there was an entire, programming and operating system world going on that didn't have to do with personal computers. And there was a lot of, software development, and there were a lot of people using software in the workplace. They wouldn't go home and do anything because they didn't have a computer. And so that's where I think it's interesting, because I think these non-consumer hardware and software companies maybe get forgotten, or their role in this is perhaps not as obvious, but they were doing the heavy lifting.
Well, it's the
software
whole
and programming.
It's the whole thing about history is written by the victors, right? So it's like beta versus VHS. People forget that beta was actually a better, from a technical standpoint, a better format.
Yeah, Guthrie, beta versus VHS. Do you even, does that mean, I don't even know. Does that mean anything to you?
Yes, I know about all this stuff.
I don't know what you know.
Of course I know about all these things.
But you're only 10 years old.
That doesn't mean
in dog
I was
years
there.
or something.
I was there for the Blu-ray versus HD DVD
Okay.
war. That
All
was
right,
really
that you
more
were
of a gentle skirmish.
A skirmish.
It really wasn't much.
Rather than a huge battle or a huge war.
Yeah, I had a friend who was buying all sorts of HD DVDs. And I was like, I kind of think like you should be buying Blu-rays, not HD DVDs. He's like, no, this is the future. And I was like, nah.
And you know, the other thing that's interesting, I mean, back then, those of us who did any computer stuff like interface design and human computer interaction, we actually had some fairly good programming chops.
Right.
Because it wasn't as specialized and you needed, so, I knew how to program. I had programmed in various languages that are no longer of any use. But I did. And I also then remember that shift from in programming when it made a shift to object-oriented programming. That was a very big deal. I remember attending an object-oriented programming class with a whole bunch of other people who were used to programming in not object-oriented ways. And and that whole object-oriented programming is the precursor to, or I mean, I guess it's a precursor. They kind of developed in their own way and then kind of met and then kind of went out again. You've got object-oriented programming, and then you have object view interface design. They have some relation. They're not the same thing.
Yeah, absolutely. And I think we should, maybe in our third of 17 installments, or perhaps third of 4, if I can predict where this is heading based on the flow of the conversation, we could get into that. That's part of the story around Xerox PARC, right? I think it was 1972, Alan Kay invented Smalltalk, which was the first object-oriented programming language, right? And that itself was object-oriented as a user interface. It had Windows types of things that we're thinking of. And and we should come back and talk in depth about OO programming, because it is 100% related to object-oriented user interface design, but they're not exactly the same thing. But in object-oriented programming, if you think about the way programming worked historically, the contrast in terms of computing models for programming is basically procedural versus object-oriented, right? And so procedural programs is but it's a set of instructions, logical instructions, conditional logic, Boolean logic, if then else kinds of things, and you execute a program by running through those instructions. Smalltalk changed that, where it created these things called objects. And when Kay invented that, there's some video that I saw at one point. He talks about almost his regret in coining the term object-oriented programming, because while the objects themselves were hugely important, the important construct in all of that was the messaging, the passing of information in between the software objects. But to go back to the OS2 thing, that's really interesting, that IBM lost, right? Windows and Macintosh won out, and IBM OS2 got sunset and didn't survive. But in terms of our specific topic of object-oriented thinking in UI UX design, IBM is really kind of the Xerox PARC for specifically the stuff that we're talking about. I had a conversation, I mentioned last time, I talked to Theo Mandel, and he wrote this book, The GUI OOUI War, Windows versus OS2. And it was really interesting kind of getting into the weeds with him on this stuff. And I think I mentioned this in the last podcast, but he has this idea that a lot of the things that we know now are object-ish not true object orientation. And there's this sort of continuum that we've touched on before. So when we get into our next conversation for the next installment, we can talk a little bit about object oriented programming, and then we can move into the nitty gritty of object oriented design, and I will perhaps start with my hypothesis about how Steve Jobs is the one responsible for both popularizing object orientation and killing it, because it is not as we could have and should have in technology today. It has actually taken a step back from this era where we just left off in our little history lesson here.
Yeah. Yeah, and so we should end things here for today, and that's a good place for us to pick up for our next one. But I just want to put out there that we are, in my view, we are not just doing a historical look, because I believe that for many of, maybe not all, but maybe all, for many of the complex interaction design that we need to do as user experience professionals, the object oriented way of doing interaction design, it's critical. It's critical, and not using object oriented design for not the programming part, but just talking about the interface design part. If you don't use it, many times, I think you're doomed to have an unusable interface. I mean, that's how strongly I feel about it. And so we're not just doing a nice historical view and then we come to the present and it's thrown away. It's like it's a really critical part of how to design that I use, Dean, you still use, and other people use. We're not the only people in the world using it. But it has, as you just said, it's kind of gotten lost. So I'm hoping we'll help revive and even popularize again some of these ideas, because they're so powerful.
Well, maybe we can start then in the next one. We'll wrap up, tie a bow around the history lesson, and I'll explain how and why it got lost.
Okay, I like it. Guthrie, take us out.
Okay.
So, Guthrie, if
I don't know what you wanted to add.
If people have questions or comments,
right.
or
yes. Email info@theteamw.com.
Yeah, and we'll address them in some of our future episodes of this series.
I didn't know what else to add.
I think that's good. That's all we need.
We will be back with another installment.
Yeah.
Next time.
All right.
Well, thanks for letting me help put the tech in the Human Tech Podcast. I appreciate it.
Well, look, you guys have to, you want to lay this all down, have it,
yeah,
have it on record. So
yeah,
there's no rush at all.
Well, I don't think we'll get to 17, but we'll finish the conversation and see how far it goes.
We know we're going at least to 3. We've already, because we're wrapping 2. So
awesome. Thanks for the time, guys.
All right. Talk later. Bye.